So hey, I'm streaming live to YouTube. This is me, Roy. I'm doing a group presentation, or the last part of a group presentation. What happened was I wasn't prepared for the first half. Can't hit on me too quick. We do our group presentation on Monday, and I get all the information. Anyway, I just wasn't on top of my game. So I'm making an addition to the end of that video. So in the first part of the video, we did questions 1, 2, 3, and 4, and my responsibility was question 5. I was hoping they could understand it, but I panicked. And so I have here on my thing, here's question 5A, and pretty much what it's asking about is it's asking about the progeny of these little cat things and their DNA. And so I have my answer here, and I'll show you how I got my answer over here. Whoa, that's cool. Anyway, I'm playing around with this thing for the first time, so I don't know if I'm actually going to post this one, but that's it. That's cool. Anyway, so I'm having a good time right now. So how it is here is we have our genes. We have our mom, who is homozygous for these two, and then we have our dad, who is, well, it's an X-linked recessive chromosome, so there's that one there. And then we have our O there. I wonder if I can get that to zoom. Oh, not too much. So here we have it set in these here. So as you can see, dad, who is orange, Y, mom, who is tortoise, and they'll come out with these 4 different ones here, and then it's shown over here on my table. So as you can see, XB or XB XO, which is the first one there, and then the 4 different phenotypes. So we'll be 25% of each one of the different phenotypes for that one. The second question talks about what does it say? The trait described in part A, male tortoise cats are very rare. What is the genotype of male tortoise cat? He would actually have to have a whole nother chromosome right there to be a male, because you'd have to have the 2 chromosomes for the X and the Y to get the tortoiseshell, or the calico. I call them calico, tortoiseshell, whatever. And then you have to have the Y one on top of that. So I thought that was really interesting and how that worked and things like that. And then in part C, it talks about the fruit fly dysplasia, and the mutation produces a scallop phenotype, irregular margins of the wings. Assume that the scallop phenotype is the result of an X-linked recessive mutation, indicate the genotypes and phenotypes the progeny produced when a reciprocal crosses are done. And so I did those reciprocal crosses here. And as you can see, the reciprocal crosses of having the female recessive and the reciprocal crosses of having the female dominant and the progeny. So if you have the dominant, they're all going to turn out to be, the phenotype's going to be the non-recessive gene, which is the regular wings. And then if you end up with the female being recessive, all the females are going to show they're scalloped, and then all the males, because they're the recessive X, they're all going to be have the scallop type wing types there. And so that's how that worked there. And then in part D, the last part of my question, it says this question concerns the scallop phenotypes. Assume that the scallop phenotype is the result of an autosomal recessive mutation, and indicate the genotypes and phenotypes with the progeny produced in the recessive time. And so if you're talking autosomal there, then you're just going to end up with this set here. When you're running an autosomal reciprocal cross, you have one dominant, one right, so you're just going to end up with everything being heterozygous. Males, females, everything's just going to be heterozygous across the board if it's going to be autosomal. And so that's my question. That's question 5. Now I have to turn this thing off. I might run through this all again just so I can remember how to turn it off.